Little Toby is flying over the forest in Southern California when he spots a large fire. He frantically rushes home to tell his mother. He's never seen a fire so large and destructive in his life. His mother explains the reason for this. Fires in California have rapidly increased in frequency and mass in the past few years. This is because recent droughts due to climate change have caused plants to dry up and be used to fuel fires. These fires have become more and more dangerous in recent years, with 8 out of 10 of California's largest recorded fires being in the last year. Wow, that sounds super bad for the environment. While fires do cause a lot of trouble, there are many benefits of them. One benefit of fires is helping to clean forest floors. The fires remove underbrush, clears debris, and removes unhealthy or dead trees to allow new ones to grow in their place, and even helps to prevent future fires that could get out of hand. Wow, there are a lot of benefits, but what about the consequences? I'm glad you asked. While forest fires are beneficial, they can sometimes get out of hand and destroy whole ecosystems. Fires can also destroy homes, businesses, and structures. California's 13 most destructive fires in the past 5 years burned 40,000 structures alone. Fires can even create health risks for many people. Smoke can cause respiratory problems, and in bad cases, it can lead to heart attacks and strokes. I'm still urging to know what makes these fires start and run. Combustion. Combustion is the burning of a fuel combined with O2 to create CO2 plus H2O plus energy. The 3 components needed for combustion to occur are oxygen, heat, and fuel. These are called the fire triangle. An example of combustion is if I was to burn this candle made of the petroleum product paraffin with the chemical structure of C25H52. The equation for this combustion would be C25H52 plus O2 equals CO2 plus H2O plus energy. Now watch what happens while it burns. It's disappearing. That's where you're wrong. According to the law of conservation of mass, no matter can be created or destroyed, only transformed. The matter in the wax turned into gases like CO2 and water vapor. It also transformed into carbon soot. Do you think you can deeper explain that to me? Of course. I'll show you a model of the atoms in combustion, which will explain how they balance. In my example, I'll use the chemical methane. Methane has 1 carbon atom and 4 hydrogen atoms. In order to make methane and oxygen create water and carbon dioxide, we'll need to add some atoms. Instead of the equation CH4 plus O2 is equal to H2O plus CO2, we will use the equation CH4 plus 2O2 is equal to 2H2O plus CO2 in order to balance the atoms. We can see CH4 plus 2O2 has 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms. Just like the first formula, 2H2O plus CO2 has 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms. This whole process of combustion is an exothermic reaction, meaning it releases heat. How much heat? To determine how much heat was released, we need to know the specific heat of the chemical, the change in temperature, and the mass. It can be wrote out using the equation Q equals mc delta T. Can you demonstrate this to me? Sure. For the example, we will calculate the amount of energy released of 20.0 grams of methane with an initial temperature of 30.5 degrees Celsius and a final temperature of 55.0 degrees Celsius. The first thing you need to solve for is the change in temperature with the equation final temperature minus initial temperature, or 55.0 degrees Celsius minus 30.5 degrees Celsius. This makes the change in temperature 24.5 degrees Celsius. We know that the specific heat capacity of methane is 2.20 joules divided by grams degrees Celsius, so we can substitute that in for C. We can substitute 20.0 grams in for M, or mass. Then we can substitute 24.5 degrees Celsius in for delta T. These substitutions will make our equation look like Q equals 20.0 grams times 2.20 joules divided by grams degrees Celsius times 24.5 degrees Celsius. This simplifies to Q equals 1078 joules. However, we are not finished. This can be simplified using scientific notation. For scientific notation, you go by the least accurate number. In this case, it would be 20.0, which has 3 sig figs. 1078 joules in scientific notation with 3 sig figs is 1.08 times 10 to the third power joules. That all is very interesting, but I'm wondering what method scientists use to study fires. They use quantitative and qualitative observations. What are those? Quantitative observations are observations made using data or statistics. Qualitative observations are things you observe and don't contain any numbers. An example of a quantitative observation would be like how 13 of California's 20 most destructive fires have been in the past 5 years. An example of a qualitative observation is saying like the color of or the smell of the flame or something that cannot be measured in numbers. Now we have to go fast. The fire's coming. Mom, explain how a tornado works to me.